Hey coding birds. So basically in today's LeetCode problem 1572, which is matrix diagonal sum, and it is also a kind of easy level of problem, and the problem statement is given a square matrix return the sum of the matrix diagonal only includes the sum of all the elements on the primary diagonals and all the elements on the secondary diagonals that are not part of the primary diagonals. Okay, so basically in the given problem here we have a square matrix, and we know very well about square matrix. A matrix that is having the same number of rows and same number of columns are considered to be like square matrix. And here what we have to do, we know very well about the diagonals of the matrix. Okay, so here if I have to explain with the example, so example one here is like 1 2 3 4 5 6 7 8 9. So we know very well about diagonal. Whenever we say about diagonal, then we mean only primary diagonal. So if we are going to take a sum of it like 1 5 9, so it will like 15. But here the problem is also like us that we have to also like take a sum of secondary diagonal. See, a few minutes ago I have like solved one more problems which is based on GFG. There also we need to find our anti-diagonal elements, and we know very well about how we can find anti-diagonal elements like 3 5 and 7. So here in this given problem here, it is a kind of easier problem of LeetCode. Here we have to just simply take a sum of primary diagonal as well as secondary diagonals and just return the single output here. So here in that case what we will do, here first of all here I'm going to define it as int sum is equal to 0. Then after that what I have to do here it is already defined that here this is my primary diagonal and here this is my secondary diagonal, right? So here we have to just make a sum of it, like this is example one here. So if we are like make a sum of it like 159 and 357, the only thing is that which we have to consider is like we don't have to count 5 for 2 times, as it is a middle element of the square matrix. Similarly, if I'm talking about the second example here, so it is like 1 1 1 1 and again 1 1 1 1. So after adding it we are actually getting 8 as an output here. And in the third example here it is considered only single element which is 5, so here 5 will be like our output here. Okay, here hint is given, there will be an overlap of an element in the primary and secondary diagonals if and only if the length of the matrix is odd, which is at the center. Okay, so this is a similar based question. Check if matrix is X matrix. Check if every rows and columns contains all numbers. Okay, so let's try to first of all solve this problem here. See, we know very about what is the approach to solve, or what is the approach to find the diagonal element. We know very well about. That means if here in the particular example here we have already mentioned that it is a squared matrix, so here it is a kind of easy level of problem because we just don't have to write it for two times. Here we just simply defines the size of matrix for just one times, okay, which allows for both, that means size of rows and size of columns. Okay, so here first of all what I have to do, here I have to traverse point I is equal to 0, I is less than, and then I plus plus. Similarly here if we say that for int j is equal to 0 and then j is like less than n and then j plus plus, and if we're like saying that if I is equal to j, if I is equal to j, then in that case we know very well about it is like a squared matrix. So in that case here we can simply do what, sum plus is equal to matrix of I and j. Okay, matrix of I and I, or j, we can also define it as matrix of I and j. Similarly, I can also do what, here we can also give another conditions for the, this is for primary, here we can say that this is for primary diagonal. We know very well this is for primary diagonal. It is a way to check about the primary diagonals. Okay, so by performing this conditional statement here we get primary diagonal. Okay, now similarly here we have to find for the anti now here we have to find for anti-diagonal elements. So here else if we can give, else if we can say if I plus j is equal to n minus 1. Okay, that means if we like take the sum of I, that means rows and columns, is equal to just matrix size minus 1, then this is the way to find the anti-diagonal elements. So in that case also we can do sum plus is equal to matrix of I and j. Okay, and then after that once we have like done these things, then that means we have like taking the sum of both like primary diagonal and secondary diagonal also. But here one more conditions which we have to give here is like we have to first of all move out from this for loop, and then after that we have to check the conditions for the middle elements, which is like count for 2 times. So for that, here we have to give the condition like here if n modulus 2, that means if it is like appear for 2 times. And so for that, what we will do here, we have to just simply subtract from the sum, that means sum minus is equal to matrix of here we define, here we just have to divide the size of matrix n by 2 for rows and as well as for column also. Okay, then after that we can just simply return our sum. Let's try to compile and run. So here I'm actually getting an error here like 1 2 3 4 6 7 8 9. So if I like taking the sum of it, it is like 20, and here our expected output is like 25. All right, so what I can do here, let me think for that. Okay, so here this is for the secondary diagonal. See, I can also do it in for a single within a single for loop also. Okay, that makes the less time complexity, which is like here I'm using the time complexity of order of n square, but I can make it as also of order of n. Okay, so I'm going to do it in the same way. Okay, so here what we'll do here, I have to just simply write I've already declared my sum. So here for sum plus is equal to um, a matrix of I and I. We know about I and I, that means if it is a square matrix, so we can say that if I is like equal to j, then in that case we can say it is a diagonal element. So here we just don't have defined for 2 times. Okay, you just simply say that if I is like equal to I, or if matrix of I, that means the diagonal element. So then we can simply add to the sum. So it is for primary diagonal. Similarly, we can also do it for the secondary diagonal elements also. So here what we will do, sum plus is equal to matrix of, here we have to define I, that means for the row, and column. For here column, what we will do here, first of all we have to define the size of matrix, that means n minus I and minus 1. Okay, by this way we can get the secondary diagonal elements. Okay, once you have like done these things, then after that we can check it here whether it is like present the middle element is like this. So we have to just simply subtract it, then after that we have to just simply return the output for sum. Let's try to compile and run. Okay, so yeah, here our test cases is like pass, and it is passes every cases. Okay, so let's try to submit it. So yeah, it's submitted. So yeah, that's all for today. Thanks for watching.